All right, wow, look at everybody here already. So give me 1 second. I'm going to switch over to the dot cam, run downstairs, grab some coffee, and then we will get started in just a couple of minutes. This is MAC 2312, section 001. Today is the 11th of May. And in just a few minutes, we'll start. We're going to start by going over the syllabus and covering all the normal kind of first day stuff. And then if there's time, we will talk a little bit about integration. But give me just a couple of seconds. Oh, yeah, thank you. Oh, you're the best. I'm gonna get fat. I'm gonna get fat. No, it's not. All right. Hey guys. So welcome to Calc 2, MAC 2312, section 001. I see there are some comments in the chat. Let me take a quick look at those and then we can get rolling. Today we are, oh damn it, this mouse. We are mostly just going to talk through the syllabus, but there will be a little bit of mathematics and I will be assigning your first homework today. Oh, I see in the chat, everybody's saying hi. That's really nice. Yeah. Hey, Naz, Dalton, Gus, Ryan. Good to see you guys. So, yeah. My name is John. And the last name is weird. It's pronounced file sticker if you're concerned, but you can just call me John. My office is A031D, and I've structured this course as a yeah, I mean, you can call me professor if you want to, but you don't have to. I am not sticklery about that at all. This is where my office is on campus, and if we are able to resume in-person lectures this summer, then that's where we'll go for office hours. But I'm not sure yet whether that's the case. So we're set up in this hybrid format where you guys have to come to the Zoom meetings at these times, because if we're able to resume lectures, we will, and they will be on campus during these times. And then that would mean we're also able to resume in-person office hours, and those would be here. My email is my first name dot my last name at sfcollege.edu. .edu, or you can Canvas message. Canvas messages are actually my preferred mechanism of communication, written communication, because it'll automatically forward to my email, and it'll have the subject line like MAC2312 and your name, which is super duper convenient. So if you want to email me, you can email me directly here. That's fine from your email address. If you do that, please, in the subject line, go ahead and say, you know, Calc 2, and make sure your name is in there, especially if you're emailing me from like a Gmail or something that doesn't have your information in the email address itself. But Canvas messages are preferred because those things are done automatically. So either way is okay. Basic plan for today, I want to go over the syllabus, make sure everybody knows how to get into WebAssign, because that's where a lot of the course material is going to be. I'll walk you around the Canvas course a little bit, and then if there's time, we will dig into a bit of actual integration material. So zeroth things zeroth. Let me close this one. That one needs to stay. Close this one. This can go. All right. So I'm going to switch my screen share now so you can see everything. Oh, of course, my mouse is not working anymore, so let me grab my auxiliary mouse here. Is that going to work? Yeah, okay. So we're going to do new share. We're going to do the whole screen. And we'll do it like this. So hopefully everybody has been able to get into Canvas. If not, please go ahead and do so now. I assume you did. You got here, so you had to get here through Canvas. This is the home page on Canvas. It's the syllabus page, and it has the basic information like my name, when class time is, office hours on Zoom. We're going to talk about this a little bit today and a little bit on Wednesday. And my goal is to have the office hours nailed down by Wednesday. I just want to make sure that the times and days that I use are times and days that you guys can come. So I don't want to schedule those ahead of time before we're able to have a discussion about that. The first thing that I would make sure to do on your end, as far as actually doing stuff, go ahead, grab your phone right now and put this in your calendar, the final exam. It's not our normal class meeting time. It's at 10:30. It's from 10:30 to 12:30. I know it's a long way off on August 11th, but if you go ahead and put that in your calendar now, then you'll never have to worry about it. I would do that with like several warnings. I would have like a 2-day warning, I'd have like a 1-day warning, and then I'd have like a 1-hour warning. That way you will not be surprised by the final. This first link takes you to WebAssign. And we're going to talk about that in just a second, but for now, if you haven't, go ahead and click this second link, and that should pop up a little dialog that allows you to download the complete syllabus. So normally this is the syllabus that I would hand out on the first day in class. Oh my. Sorry, I spilled some stuff on my laptop. Damn it! And the mouse has become all sticky and terrible. Are you gonna work or not? There we go. All right. No. There we go. Just use the keyboard. So here's the syllabus, and hopefully you all have this open on your end. You may want to print a copy of this if you have a printer. There's a lot of important stuff in here that you'll want to refer back to through the course. At the top there, you see my name, my email, the office. This phone number is my office phone number, and I have it forwarded to my cell right now, but I cannot retrieve any voicemail. So phone is not the best way to get a hold of me. Let's just say that, right? Calling that number will make my cell phone ring, but it's going to say that my office is calling me. So I won't know it's you. I won't know who it is that's calling, and also I can't retrieve voicemail. So if there's like an emergency, if you're trying to get into a test or something like that online and it's not able to work, then you can call that number. But Canvas messages are really the best way to get a hold of me. So just be aware of that. I cannot retrieve voicemail from this number, but it is an effective way to reach me still, even though I'm not on campus. Class meetings are, of course, Monday, Wednesday, and Friday from 11:30 to 12:30 on Zoom. If we're able to resume in-person instruction, if the COVID lockdown ends, then we will get a classroom assigned and we'll go back to doing it the normal way. But for now, this is how we're going to do things. Office hours, like I said, TBA. I want to talk with you guys a little bit today and a little bit on Wednesday about when would be the best time and day for office hours, because it's very important, especially in this class, especially in Calc 2. It's so important that I'm able to see your work and we're able to have a back and forth about it, because the notation in this class is challenging. The content in this class is challenging. But even if you're a master of the content, just writing things down correctly is challenging. This is a hard class. And so it's very, very important that I'm able to see your work and give you feedback on it, that you're able to see my work, that we're able to have a meaningful back and forth. So when we have this office hour discussion, please take it seriously and let me know what times would work for you. The final exam is when we said it is. Stupid mouse. As we move down, so Calc 2 is Calc 2. It's the second in a 3-course sequence on the fundamentals of calculus, Calc 1, 2, 3. Calc 1 is mostly about the derivative and rates of change, limits, things like that. Calc 2 is mostly about integration at the start. The main topics that we're going to cover are integration techniques, applications of integrations, sequences and series, power series, representing functions as power series, and then 2 little fun topics at the end, parametric curves and polar coordinates. You can basically think of this as a class in 3 parts. The first part is integration. The second part is convergence, which is hard. That's the thing that gives this class the reputation it has. Sequences, series, improper integrals. As soon as I use the word converge for the first time, we need to all be in like ultra serious mode where we're studying hard every day, because that is genuinely tricky stuff. There's a lot of challenging concepts, and not just the concepts, but also the notation, and really everything there is challenging for most folks. But it's cool. It's actually really beautiful. It's some of the most amazing stuff in the world. I think of this as like the intro to real analysis. So the stuff that we do in the middle third of this course when we talk about convergence is foundational for every bit of mathematics that lives above this. And the last bit of this course, the last third of this course, is applications. So first we do integration, then we talk about convergence, and then we talk about applications. The application stuff at the end is a lot of fun, but you need to have a solid grasp on the first 2 things in order to play with them. Cell phone policy, this is not especially relevant right now, but just don't use tech in a way that distracts other people, that's all. So try not to have a TV on in the background and your mic unmuted, that sort of thing. If you're going to use a virtual background in Zoom, let's not have like explosions and dancing kitties and all of that stuff. Let's keep it simple and non-distracting. And when we do resume in-person classes, if we do over the summer, that extends to all the obvious things, like if you're going to scroll Reddit or Snapstagram, make sure you're like sitting in the back, or you have the volume down, whatever. You guys are all adults, just be polite. Attendance policy. I am going to take roll. I have to take roll not just for financial aid purposes, but also so in this online setting, I can see if there's anybody who's having a hard time getting to the classes, getting to the lectures, and I can reach out to them. But also it's very important for financial aid purposes. Your financial aid will not disperse until I mark you as having attended. Makeups are pretty straightforward. Just talk to me. If you miss a test, let me know. Let me know as soon as you can. Ideally, let me know before the test. But if you miss or are going to miss a test, just talk to me and I will arrange a makeup for you. I do not drop a lowest test score, and I don't usually replace low test scores by the final. I know that that was a policy that was instituted during the COVID-19 shutdown that may still be in place, so we may end up replacing the lowest midterm by the final, but it is not a part of my normal syllabus. It is not a part of my normal policy. If you miss something, just make it up. That's all, rather than having to worry about any sort of replacement. So if you're going to miss a test, if you know you're going to be out of town or something like that, please let me know. If you know that for whatever reason you won't be able to take a test, just let me know. If you happen to miss one and you didn't let me know ahead of time, that's not great, but it's not the end of the world. Just reach out to me. We will put together a makeup. The rule is makeup got to be done within a week. All right, so if you miss something, we need to get it made up within a week. If you miss a homework or something like that, then that's no big deal. I'll extend those. I got no problem extending homeworks. But if you miss a test, we do need to talk. Homework and study guides, right? So every week there will be a WebAssign homework, and we're going to talk a little bit about WebAssign today. So each Monday I will open that week's homework, and it will be due the following Monday. So today I'm going to open your first homework, and it will be due on the, what's that going to be, the 18th? Yeah, the 18th. So your first WebAssign homework is going to open today and be due on the 18th of May. And that's how the homework will work every week. Like I said, if you happen to miss one or not have one complete, just submit an extension request and I will grant it, I promise. Then the other thing is the study guides. So about a week before each of our midterm exams, we're going to have 3 midterms and a final. About a week before each of the midterms, I will send you a study guide, which are some homework-like problems that you're going to write out very nice, careful solutions to. And then those study guides, we're going to talk about in office hours, right? You're going to bring the hard problems to me in office hours. We're going to be able to share work, and I'll be able to look at what you're writing and give you some feedback. That way you don't come into the test wondering, what does he expect from me? You'll know. That's the purpose of the study guide, is to give you some exam type problems that you can work on your own time, and we can discuss before the test so that you won't be surprised by the standards I'm going to apply on the test. The study guides are valuable even if you and I don't talk about them, because you're still working hard problems. But in order to get the most out of the study guide, you need to start it as soon as it's released, and you need to bring your work to an office hour, one of our virtual office hours works, in order to discuss it and share it. And so I can tell you, oh yeah, well, make sure you write the DX here, or make sure you don't do this there, or little things like that. Very worthwhile. So please start the study guides early and bring them by an office hour at least once before the test. Lab meetings, normally one of our meetings each week would be in Building X, where we have computer lab for you guys to play around with. But for the most part, my labs are just recitations anyway, where we solve problems. Only a few of them actually involve the computers. And with this online system, basically you can pretty much just ignore this. Obviously, I cannot put you guys into a computer lab right now, but there will be occasional things I ask you to do using like Desmos or something, some online computer algebra system. The tests, so like I said, they're going to be 3 midterm exams and 1 final. So the 3 midterms are going to take place during class. They're going to be on WebAssign if we're still online, or they'll be in person and actual on paper if we are allowed to. I'm not sure how that's going to go just yet, but 3 midterms and 1 final. Thank you, baby. If we're still online, then they'll take place on WebAssign, and we'll be using HonorLock to proctor. So if you've worked with HonorLock in the past, that's awesome. If you haven't worked with HonorLock in the past, we need to make sure that that you can, in the event that we have to take our first few tests online. I think it's very likely that we'll take our first few tests online, although I don't have any definitive word from the college yet. The final exam, again, is 8/11 at 10:30, so go ahead and put this in your calendar somewhere that you'll get a reminder, because it's not our normal class time. If you show up at 11:30 for a final that starts at 10:30, you're going to be really sad because you'll have missed half of it. Important dates, these are other things I would put in your calendar on your phone, maybe with a 1-day warning, like a 1-day notification. Classes start today, of course. The last day to drop with a refund. So if you decide, oh, I really don't want to do Calc 2, especially not like this, or especially not with him, or especially not online, whatever, for whatever reason you decide this is not the way to do it, last day to get your money back is the 15th, which I think is this Friday. And then we've got a few holidays. So Memorial Day is the 25th of May, and then we are closed on the day before the 4th of July, as well as the 4th. The 4th falls on a Saturday this year, so we're going to be closed the Friday before that also. Another one I would make sure to put in your calendar, the last day to drop with a W is the 13th of July, which is right around the time of our exam 2. So hopefully we'll have exam 2 done by this time, and you'll be able to have a stronger feel for where you are grade-wise. But make sure you put this in your calendar, and as that day approaches, we want to take an honest, hard look at how things are going and decide whether or not you want to proceed and finish with a letter grade in this class. If you decide that's not the case, then the last day to bail without any impact on your GPA is the 13th of July. Last day of class is 8/7, final exam. Again, I put this everywhere in the syllabus. and then grades will be posted. You'll be able to see your final grade on the 14th of August. The breakdown for the grade is here. It's pretty straightforward. You've got the homework, which is the online stuff in WebAssign. That's worth a total of 45 points, or about 8% of the grade. The study guides, so that's one of these before each exam. That's your careful written solution to those problems that you will scan using an app like Cam Scanner and submit to me on Canvas. Those are worth 25 points each for a total of 75 points, altogether worth about 13%. So all of the study guides together are worth about the same as one of the midterm exams, right? Just a little bit less than one of the midterm exams. Each midterm is worth 100 points. There's 3 of them, so that's a total of 300 points. Or about 53% of the grade coming from the midterms. And then the final exam is 150 points, is worth about 26% of the grade. What you'll see is that the vast majority of the grade comes from the tests, right? Comes from the exams. About 21% of the grade between the study guides and the homework. All the rest of it is coming from the tests. So it's very important that you prep for these tests, that you're ready for them. They are likely to be online. I am not personally expecting us to be able to resume in-person instruction anytime soon, just based on the chatter that I hear and the things that I see and whatnot. But I will be collecting your work and scoring it for partial credit. So the way this is going to work, the tests, if they are on WebAssign, you will go into WebAssign, it'll be proctored with HonorLock, but you're gonna have to write out all of your work, all your scratch work, and you're gonna submit that to me on Canvas after the test using, again, an app like Cam Scanner or something like that. And then I'll go through that work and add some partial credit or remove partial credit, as the case may be, based on your work. But the exams are where most of the grade comes from, so you wanna take them very seriously. The grade scale is the normal one, like 90 to 100 is an A, 80 to 90 is a B, and so on, with the top 3 points in each category earning the plus designation. The next page here in the syllabus is pretty standard boilerplate stuff. The GELOs, General Education Learning Outcome, is not something that students ever really need to worry about. It's something that the state asks us to track. And usually we assess that on the final, but with the COVID shutdown, we're not doing any of this at all. So it never affects you at all. It never affects your GPA, your grade, or anything like that. There's no mark on your transcript, but it's some statistics that we usually track. So I usually have to tell you, but this semester, we're not doing it at all because of the weirdness with coronavirus. Academic integrity, this is a big deal, especially in the online setting. So please read these rules, right? If you download the syllabus, you can just click the link. Make sure you know what's expected of you. I know that in the online setting especially, it can be very tempting to play a little loose with the rules. I don't like having to bring academic integrity cases before the board, but I absolutely will do it. It's important. It's important because I need to make sure that the grade I'm assigning you is reflective of your skills, because that's what gives your degree its value, right? The degree doesn't have any value unless the people who give you that degree gave you those grades based on your actual skills, and that way the degree confers your skills. So we have to take this very seriously. Please just don't cheat, right? I abhor cheating, and I will, you know, I will fight against that in every way that I can, including setting up academic conduct cases and board hearings and stuff like that. I really hate to do it though, so I would just much prefer that everybody be honest. Usually it's not a problem. So please, please, please read those rules, follow those rules. Just don't cheat. That's all. Just don't cheat. Very simple. The ADA thing, so if you have any sort of disability, whether you're working with the DRC before or not, just reach out to me and I'll do everything I can to accommodate you. The DRC is still running. They actually still have humans in the building also, not just remotely. So if you want to work with them, or if you have worked with them in the past, or if you're wondering if they're available to work with now, the answer to all of those is yes. And I would be happy to help you with that and help meet any accommodations that they recommend. Whether you deal with them directly or not, we can usually handle things like extra time pretty well in this remote setting, right? I can just build that into the tests and quizzes as needed. But if there's anything else like that, or if you want to talk about stuff like that, just send me a Canvas message. I'll be happy to work with you. Discrimination and harassment, this is pretty straightforward. Just don't be an asshole. please be nice, right? Yeah, don't harass people, don't discriminate, don't be a jerk. Treat everybody with the respect you want, and everything will be fine. Lastly, students' rights and responsibilities. Like this academic integrity stuff, I suggest clicking this link and reading these things. These are the standards that you're being held to, whether you know it or not. And so it's important, I think, that you know what standards you're being held to. The last page of the syllabus here is a rough course calendar. So this is approximately when we will cover each of the topics and when we'll have each exam. It might move around. So if I feel like this stuff is really easy for you guys, and for whatever reason you're just blasting through this, then we might combine some of these. Or if I feel like this stuff down here is really hard for you guys, for whatever reason we're taking longer to get through that, I might stretch that bit out a little bit. But this is a fairly good idea of when we will be talking about what things. So this week we're going to talk about substitution and area problems. We'll talk a little bit about average value and areas between curves, that sort of thing. And then next week we're going to talk about volumes. There's two different ways to find volumes of three-dimensional solids using integrals. And we will learn those two methods. And then after that, we're going to go on to trig sub and partial fractions, all sorts of good stuff. But you see what I mean here about the course being broken up into thirds. This is the first third, and it's all integration. This is the middle third, and it's all about convergence. And this is the last third, and it's pretty much all about applications. The power series stuff is sort of an application of the convergence stuff. So really this week 10 material here, this is tough stuff, and it is a continuation of the convergence discussion. I just put it on exam 3 so that exam 2 isn't terribly brutal. If I put all of this, the Taylor's theorem stuff, on exam 2, then exam 2 would be ruthless, and exam 3 would be too easy. So to try and break it up and make life a little bit easier for you, we stretch some of the convergence stuff. So everything before week 6 is about integration techniques. Everything up to here is about convergence, sequences, series, that sort of thing. And everything after here is about applications. The middle third is the tough part. Okay, the first third of this class is not easy either, but the middle third is undeniably the hardest part. So that's the syllabus. I want to come back and talk a little bit more about a few things here, namely this thing. So I think most of you have probably used WebAssign before because most Calc 1 classes use it. But just in case, if you click this link, so it's in Canvas, I've got a link there that will take you to WebAssign. You can also just type webassign.net into the address bar. That's all that takes you to. You can go here to login. And if you have a WebAssign account from previous class, you can either just sign in. If you don't remember your password or whatever, you can come down here. If you don't have a WebAssign account yet, you can click here to enter class key. Either way, if you sign into your old account and you haven't entered the class key for our course yet, they'll give you the opportunity to enter the class key. Otherwise, you can just click the button there that says enter class key or enroll with class key. Yeah, it's not super complicated at all. If you do have trouble, any sort of trouble getting into WebAssign, go back to their login page. Maybe one more. Yeah, go back to their main page. If you do have any sort of trouble getting in there, you can click support and come down here to student support. And there's a little video that will walk you through how to get started in WebAssign. So if you click this guy, this has a little tutorial to get you set up, and it's got a little FAQ down here that will help you get registered. And if you are really running into trouble, if that video isn't helpful or if the text you see under the support thing there isn't helpful, you can always call this phone number, 800-354-9706, and someone there will be happy to kind of walk you through and make sure you get registered. The one thing that I would really like to see from you guys today, my goal, is to get everybody registered in WebAssign. So today, please get into our class in WebAssign. I published the Canvas course for our class a few days ago, and I see that a few people have already gone through and read everything and jumped into the WebAssign class. That's awesome. But if you haven't, let's go ahead and get on that. Let's go ahead and make that happen. So the sooner you guys get in there, the sooner you can get started on the work, and the sooner we can actually get moving with the course material. Let's take a quick second to pause. Any questions about the WebAssign? Nice. Okay. So you will need an access code. The two things that you'll need to get into WebAssign, and I see here, yeah, we've got 16 people already enrolled. That's awesome. You guys are great. The two things you will need to actually get into WebAssign are the class key, that's this, and the other one is an access code. Now, even if you haven't purchased an access code, the access code is like buying the textbook for the class. It's the thing that costs money. Even if you don't have the access code, even if you haven't purchased one yet, you can still enroll with our class key and get in there. There's a 2-week trial period. So you'll be able to use WebAssign until the 25th of this month, even if you haven't bought an access code. Just when you get to the place in the registration where they ask you for one, look around that page. I think it's towards the bottom and like a grayed out, like a grayed out link that says click here to use temporary access, and that will work for the first 2 weeks of the class. Yeah, that's okay. So if you've ordered an access code and you haven't gotten it yet, you can still get in. Just go ahead and start registering as though you have the access code. When they ask for the class key, put in this number, this code from the syllabus here. And then when they ask you for the access code, scroll down to the bottom of that page and look for the link that says continue with temporary access or use temporary access or use trial access. I forget the exact wording. But even if you don't have your access code, you should be able to get in there, and you need to get in there because we're going to have a homework opening today. Am I forgetting anything? We talked through the syllabus, right? Anybody have any syllabus type questions? Any where does the grade come from, or what's expected, or what do you need to do type questions? Remember, if you're kind of new to Zoom, you can hold down the space bar to talk. That will temporarily unmute you. So it's like a push to talk button, or you can, of course, type in chat. So any questions about how to get started on the class? I'll to work on the study guides with you. Yes, and I want you to work on the study guides with me. Yeah, so solve as many of the study guide problems as you can on your own. But then the ones that are tricky or the ones that you're uncertain about, I want you to bring to office hours so we can talk about them together. The lab only run using the regular class time will be a study guide before the final. The labs are strictly for action. So I'm not 100% sure what you're asking, Nick, about the lab only running during the regular class time. So normally we would have 1 day a week where we meet in building X as opposed to in our regular classroom. But since all of our meetings right now are online, it's not relevant. Will there be a study guide before the final? I don't usually put together a study guide for the final because typically everybody at that point in the semester is very, very busy, and I don't want to load you up with extra stuff. So there are the 3 study guides, and then if you want extra material to study for the final, I can give you some, but there isn't a graded study guide before the final because I don't want to overload you guys with stuff. Normally the way the labs would work is, yeah, they're recitation sections. If you've heard of that before, it's like a problem solving session. And people could present solutions to homework problems on the board in the lab for an opportunity to earn extra credit on the upcoming midterm exams. But again, because we're doing this online thing right now, the whole lab structure that I usually use is kind of out the window. So we won't be doing that on Fridays. We will just have a regular class meeting. So basically the way to think about this is that there really isn't any lab over the summer. There really isn't any lab right now because of the COVID shutdown. So we'll just have the 3 class meetings, Monday, Wednesday, and Friday. Normally that Friday meeting would be a lab meeting where you guys would solve problems with me in the lab. But right now we're just doing it like this. We'll have these 3 meetings, Monday, Wednesday, and Friday. Any other questions about the organization of the course or what's expected of you guys? All right, so for now, for today, the only thing that I'm asking you guys to do is to go ahead and get enrolled in WebAssign. I'd love to see everybody on the roster there. If you have the impetus to do a little bit more, of course, I will be opening up a homework for you here, and you can and should begin working on that as soon as possible. But I've also got some kind of refresher stuff from Calc 1 that you might find useful. So each time we cover a major topic, I will post a module in Canvas with links to videos and outside resources that you might find useful. For example, Paul's online notes. Paul is a professor at Lamar University. Excellent stuff. Here he's covering the basic Calc 1 stuff from integrals. Right, so indefinite integrals, computing indefinite integrals, substitution rule, more substitution rule. These are things that folks tend to need a little bit of review on coming out of Calc 1. And so, this is a really good review. He not only has examples that he works, and then he has the result there, the main tool, but then he also has worked examples here with solutions that you can reveal even just a little bit at a time. And then he also has practice problems for you. So this website, while not an official part of our course, is something that I will post links to from time to time because it's full of shit that will be really useful for you, especially if you want to go back and review some of the material that is a little bit sketchy from the end of Calc 1. The other thing that you'll be seeing me post a lot of here are Patrick JMT videos. So this guy is a math YouTuber, and he works example problems out on this little whiteboard, and he does it very carefully, and he explains things very, very well. So if you're ever having a hard time with something,
all right, in this video I want to talk about some just basic
I recommend seeing if Patrick has a relevant
basic,
video.
I mean,
the audio on this is a little nasty.
So my square root of x, I'll rewrite that as x to the
But
1/2.
you get the picture. Really good stuff.
It's at first sight
exactly the right pacing and exactly the right difficulty for our class, for this class, for Calc 2. So those are the things that you'll see me posting a lot of in the modules. Occasionally I'll post something else too, but those are my two primary resources for review or supplemental material. So if you're a little bit nervous, you're not sure you remember all the details of inverse trig functions, or how to do a U substitution when you need to change the bounds, all of that stuff, that's good stuff to review here. That's the syllabus. Let's come back to the doc here. Okay, so any other questions about the organization of the class or what I'm asking you guys to get started on here? Yeah, it happens. It does. It's not the case that that every Calc 1 class spends as much time on integration as they should. I'm not seeing any fresh questions here, so I wanted to start on the actual mathematics. The homework for this week is not strictly review stuff, but it is. Let's see. Sorry, so I can take a look at what I put together for you guys. I think it's a combination of review stuff and new stuff. So section 5.5, that is review. That's substitution. 6.1, that's areas between curves, which if you had a good Calc 1 class, they should have gotten to that at the end. But 6.2, 6.3, 6.5, that stuff is all new. So the first bit of material here in homework 1, and I may break this down just a little bit. has some review stuff, some maybe review depending on how far your Calc 1 class went, and some stuff that's definitely not review. Cool. Any other questions like that? Organizational stuff? Yeah, that's how it usually tends to go. So Lucas was saying that his Calc 1 class touched on 6.1, but didn't really get to spend a lot of time on it. Where I want to begin with the actual material with you guys is I want to work a few 5.5 problems. I want to make sure we're all comfy doing substitution and doing it right. I am very picky about how you do your substitutions. I know that in many Calc 1 classes, they say with a definite integral, oh, you don't have to change the bounds. You can go back to the original variable at the end, or it's up to you. It's not up to you. You got to change the bounds. So I want to make sure that we're all comfy with that. And we're all comfy with what's going on with the differential terms. And so let's take a look at one or two problems of that sort. This is fine. Yeah, we can look at, so. So the basic idea is somebody hands you an integral and you say, oh, well, I recognize the thing inside the integral, we call the integrand, as being a composite function, a function within a function. So maybe you have something like the integral from 0 to 1 of the cosine of t pi over 2 dt. At a glance, what I think here is that, well, okay, I know how to integrate good old-fashioned cosine. If it was just cos of t dt that I wanted to integrate, I know that sine t differentiates to cos t. So I would evaluate sine t between those bounds and call it a day. But unfortunately, it's not just cos t, it's cos of something a little bit more complicated. And so in order to make this go, I need to make a substitution. I'm not referring to this as u substitution because often I like to use a different variable. The variable u, or the symbol u, we're going to be using when we talk about integration by parts. So in order to avoid confusion, I usually use the symbol z for my substitutions. And I'll always cross my z's like that so you can tell that they're not 2's. I'm going to substitute for the inside. And then every time you do a substitution, you need to calculate the differential term. This dt needs to be turned into a dz. And the way you get dz in terms of dt is by looking at this relationship, z equals t pi over 2, the substitution I'm choosing to make, and you differentiate on both sides with respect to t. So if I were to do this very slowly, I would say dz dt, the derivative of z taken with respect to t, is, well, what do I get when I differentiate this? If I differentiate t times pi over 2, that's the same as just having pi over 2 times t. So this is just pi over 2, which means dz is pi over 2 times dt. And then I need to replace dt by some dz stuff. So I need to solve this relation here for dt. So my last move would be to say, okay, well, dz divided by pi over 2 is equal to dt. So this is what I'm going to plug in for dt. And then everywhere I had t times pi over 2, that's now just z. The other thing I need to do is to change my limits. So when t is equal to 0, what is z? Well, if I plug in t equals 0 here, z would be 0 also. Right? T times pi over 2 is 0 times pi over 2 is 0. And when t is equal to 1, my old upper bound, z is equal to 1 times pi over 2 is just pi over 2. So this is all the stuff I need to make my substitution go. And you are required, right? I'm not going to mince words about this. You must change the bounds in your substitution. Every time you substitute in a definite integral, you have to change the bounds. Otherwise, the two integrals aren't equal to each other. And in this class, we want things with equal signs between them to actually be equal to each other. Would u be t pi over 2? Yeah, yep, so that's the substitution we made here. I just wrote z instead of u. So u equals t pi over 2. And then here are my old bounds. My old bounds were 0 to 1. And when I plug in t equals 0 to my substitution, I get z equals 0 out. So my new lower bound is also 0. When I plug in t equals 1 to my substitution, I get z equals pi over 2 out. So my new upper bound is pi over 2. And then this is the stuff we need to replace our differential. So altogether, this integral is equal to the integral from 0 to pi over 2 of the cosine of, well, t pi over 2, that's z. So this is just cos z. And then dt, this piece, is dz divided by pi over 2. It's crucial that you get everything in your new integral in terms of the new variable. This new integral can't have any t stuff in it anywhere. Can't have any t's in the integrand, can't have any t's or dt's in the differential, can't have any t limits for our limits of integration. Everything has to be swapped over. What you're really doing here is called a coordinate transformation. You're going to see a much more general version of this in Calc 3 when you talk about so-called Jacobian matrices. But we're doing a coordinate transform. We're taking this area problem. Remember, you can think of this as the area underneath this function over this range for t. If we do this correctly, that area will be the same as the area under regular cosine times this constant from here to here. So it's a transformation of coordinates. We're changing from t coordinates to z coordinates. This divide by pi over 2, that's the same as multiplying by 2 over pi, and that is a constant, so it can come out of the integral. And I just end up with this, 2 over pi times the integral from 0 to pi over 2 of cos z dz. And now, like we said, if this integral was just cosine, right, rather than cosine of t times pi over 2, I know that sine differentiates to cosine. So an antiderivative for cos z is sine z. So this will be 2 over pi times the sine of z evaluated from 0 to pi over 2. And this is the notation I use for evaluation. I know some people just use the straight bar instead of the brackets like that. Either one is fine. I'm not picky about that notation. But make sure you're very careful with your integrals. Always write your differentials. Okay, do not leave off the dt, the dz. That shit is so important. Always change your bounds. Anytime you make any substitution in a definite integral, you must change your bounds. And then the antiderivative step here is really easy, right? Antiderivative for cosine is sine. So now I need to actually do the evaluation step. This is the same as the sine of pi over 2 minus the sine of 0. And that's the magic of changing your bounds, right? Since I changed the bounds from 0 to 1 to 0 to pi over 2, I don't need to go back to the original variable. That's the whole point. You're taking this problem, which is in the t coordinate system, and changing it to this problem, which is in the z coordinate system. And since you did it right, you changed your bounds, you don't need to go back to the old variable. So never bother going back to the old variable in these definite integrals, in integrals with bounds. Just change the bounds and use the new bounds. The sine of pi over 2 is 1. The sine of 0 is 0. So the stuff in this bracket is 1 minus 0 is just 1. So the outcome here is just 2 over pi times 1, which is 2 over pi. So this is a good boilerplate, like simple substitution problem. Make sure you're taking good notes. make sure everything I write here, you are writing also. And then make sure you're comfy with every single step. So take a second, look at your notes, make sure you've got everything there that I have here, and then take a look and see if there's anything you'd like to ask about, any one of these steps that we're curious about. So my substitution, Lucas is asking, how did the bounds change? How did I know what to change the bounds to? The trick is this guy. To change bounds, plug the old t-bounds into the sub. So my substitution here is z equals t times pi over 2. So when t is 0, I get z equals 0 times pi over 2, which is 0. And when t is equal to 1, I plug in t equals 1 here, I get z equals 1 times pi over 2, which is just pi over 2. So I'm plugging in my old bounds, which were t values, into this substitution to get my new bounds, which are z values. Nope. So there are a few questions here. Let me make sure I'm not missing any. So going back to Fernando's question, I'm using the variable z instead of u because it's a good habit to get into. The first thing we're going to talk about in chapter 7 is called integration by parts, and that's a formula that has the symbol u like baked into it. And so if you do a substitution and then you do integration by parts, you might confuse yourself because you could overload the symbol u with two different meanings. So I prefer to use any variable other than u, x, y, w, anything. If you want to use u, that's fine. So Thomas asked, will I take points off if you use u or v or w instead of z? Nope, you can use whatever variable you want. Just be careful in a problem where you do both a u substitution and integration by parts that you don't overload the notation, that you don't overload the symbol u with multiple meanings. You want each variable to have one and only one meaning. So I use the symbol z because we don't use it for anything else in this class. It's a safe symbol to choose to use for your substitutions. Kenneth asked if class is being recorded. Yep, I will always record these lectures and I will post them to YouTube afterwards. I will post the link to get to them on YouTube in the same announcement where you found the link to join the meeting. Simon asked, is it okay to skip a few steps when we write things down? So that's a good question and it's important. If I was looking at this and asking what is the minimal stuff, you could maybe skip this step. And you could maybe skip this step. So the things that aren't covered by pens are the absolute min. And this stuff here, so you need this, you need these. If you see the dz dt relationship right away, you might just write this or you might just write this. But as far as main steps, there's not much here that I would omit. Like if you're able to jump from here to here, having done all of this, that's okay. If you're able to jump from here to here, doing this in your head, that's okay too. But make sure that you have this step somewhere. This is crucial. I don't want to clutter the notes too badly. Make sure you have this, right? Your fully transformed integral where you've got the integrand in terms of z, the differential in terms of z, the bounds in terms of z. Make sure you have the antiderivative step somewhere nice and clear. And then make sure you have the results somewhere nice and clear. And those are subtle questions that we'll have to talk about a little bit more. So as we go through and you have these questions, it's very important that we talk about them and that you show me your work. And I can be like, oh yeah, well in this problem, you might want to write a little bit more. Rakib asks, how do you find the dz dt stuff? So we're just differentiating. Let's do one more. Let's do one more. So what I did to find the dz and dt stuff is I took this relationship, z equals t times pi over 2, and I differentiated on both sides with respect to t. Z becomes dz dt, just like y becomes dy dx. And t pi over 2 became pi over 2 because that's the derivative of t times pi over 2. Well, let's do one more example. One more kind of simple example like this. Yeah, no problem. Taking the derivative of z, can I directly move the dt to the right-hand side? Yes. So Fernando asks, is this step necessary? Where I write dz dt equals pi over 2? Absolutely not. No, yeah. And most of the time, I won't write that down. So I wrote that down here as a helpful tool for folks who maybe don't remember how to get to here. But yeah, most of the time, I will not be writing that step. Most of the time, I will go straight from this to this. So let's see that. Let's see one of these worked with the level of detail I would expect from you rather than the level of detail I use to try and remind us of things we might have forgotten. How about, let's keep it simple. 0 to pi over 2 cos x sine of x. So you'll see before I start an example problem, I'll always write e.g. That's a Latin abbreviation for exemplis grati, or for example. So for example, let's look at the integral from 0 to pi over 2 of cos x times the sine of x dx. Yeah, okay, cool. So, oh, sorry, I accidentally launched my Power Manager. Hopefully that won't clog things up. All right, so again, what I see here is kind of a function within a function. If this was just the sine of x, not the sine of the sine of x, I know how to integrate that. I also have this cos x floating around, and that's going to turn out to be very important for the substitution. What I want to do is substitute for the inner function, but I need to have the pieces around that will allow me to replace dx by dz or by du. So first I'm gonna rewrite this as the integral from 0 to pi over 2 of the sine of x. And remember, this isn't multiplication, this is function composition. This is the sine of x inside the sine function. And then I've got out here cos x dx. So then if I wanted to make the substitution, I would let z be the sine of x. And then to calculate dz, I just differentiate on both sides. So dz is the derivative of sine x, that's cos x dx. So if you don't remember the notation for differentials, you can just write dz dt and then multiply both sides by dt to get here. That's what I did on the last example, but usually I'll just write this. Also, I need to change my limits. When x is equal to 0, z is equal to the sine of 0, right? I just plug in here. So when x is 0, z is equal to the sine of x, that is the sine of 0. The sine of 0 is 0. So when x is 0, z is 0. And when x is pi over 2, z is equal to the sine of pi over 2, right? Again, I just plug the old x bound in here. The sine of pi over 2 is 1. And I always like to put my substitution stuff in a little box like that. That way you don't confuse it for the main flow of work over here. You've got everything you need for your substitution right there. What I see is that this piece is exactly equal to dz. So the cos x dx part, I will just be replacing with dz. And this piece is going to be the sine of z. We remembered to change our bounds, so make sure you plug in the new bounds here. If you write this as being equal to the integral with the old bounds, you're actually telling a lie. It's not true. But what is true is that this is equal to the integral from z equals 0 to z equals 1 of the sine of z dz. Does everybody see where this is coming from? This little piece inside here, this is just z. So sine of x times cos x dx is the same as the sine of z times dz. And then my old integral ran 0 to pi over 2. My new integral runs 0 to 1. And I get the new bounds by plugging the old bounds in here. So when I plugged in x equals 0 to this equation, I got z equals the sine of 0, and the sine of 0 is 0. So my new lower bound is 0. When I plug my old upper bound, which is pi over 2, in here, I get z equals the sine of pi over 2. Sine of pi over 2 is 1, so my new upper bound is 1. So this is the integral that this guy is equal to. And again, the antiderivative step is now easy, right? Because I just have the sine of z, I have to ask who differentiates to become sine of z. It's not cos of z, right? The derivative of cosine is negative sine. So it's going to be the negative of cos z. So here's my antiderivative step. And I'm going to evaluate this from 0 to 1. And then finally, that is the cosine of 1 minus the cos of 0. Oh, sorry, negative cos. So that's negative cos of 1 minus the negative cos of 0. Yeah, sorry. Apologies. The cosine of 1 is not a nice number. I have no idea what the cosine of 1 is, but the cosine of 0 is a nice number. What is the cosine of 0?
One.
Yeah, good. Cos of 0 is 1. So this is negative cos 1 minus minus makes plus cos of 0, which is just 1. So if you're feeling fancy, maybe you might finally rewrite this as 1 minus the cos of 1. And that is it. So these are two very, very straightforward substitution problems. This is an example of the least you can write. Yeah, you don't have to underline these and call them z and dz. I did that for your purposes. But each one of these steps is necessary. So some what's a kind of minimal work look like? This would be the minimal amount of work I would want you to show. If you omitted any one of these steps, then I would be concerned. Maybe this step. All right, I guess if you wanted to, you could omit this step. As long as you actually change the bounds, if you do them in your head instead of writing them here, that's okay. But there will be, in the future, when we learn other substitution techniques like trig sub, there will be other kind of things that make sense to write over here. So I would recommend getting in the habit of writing them. I think it's a good idea. It allows you to go back and check your work. But yeah, if you didn't write this explicitly on the paper, as long as you actually change the bounds and the new integral has the new bounds, I wouldn't take off points. All right, we have time for a little bit more, right? We go to 1250. So let me look at one or two slightly more challenging substitution problems. And replace c with the new bounds and not sin x. Yeah, exactly. Yep. That's the best part about this. When you change the bounds, you don't have to go back to the original variable at the end. You can just plug in those new bounds. It's so awesome. It saves you so much time in writing. And in problems where you do 2 or 3 substitutions, one after another, and you chain that together with other techniques, the last thing in the world you want to do is have to go back through all of those substitutions and replace all of those variables. If you just change the bounds as you go, then you can use those bounds at the end. It's very, very nice. Yeah, so at no point do we need to go back to the original variable or the original bounds. We just do everything in terms of the new stuff. And yeah, that is the beauty of this. Okay, there's 2 more types of problems, substitution problems I would like to look at with you guys before we dig much further. Where did that go? There was a tricky one here. Yeah, that's a good one. So let's look at the integral from 0 to 1. One over 1 plus the square root of x all raised to the 4th power dx. Sorry if that's not clear. This is a square root symbol. So you've got 1 plus square root x. All of that is raised to the 4th power and put downstairs. And then we want to integrate that from 0 to 1. The trick here is figuring out how to make the substitution go, right? What sort of substitution should I use, and how do I make it work? What I see when I look at that is that if this was just 1 over x to the 4, just 1 over u to the 4, I know how to integrate that. That would just be a power rule thing. So my first thought is to try and sub for the stuff in the denominator that's being raised to that power. So let's let z be 1 plus the square root of x. dz then, I maybe need to think about this derivative for a second. X, the square root of x is x to the 1/2. His derivative then is 1/2 times x to the 1/2 minus 1, which is 1/2 times x to the negative 1/2, which is 1 over 2 square roots of x dx. So check that derivative. It's a power rule derivative. It's not hard, but you do need to be a little bit careful. And if you haven't been practicing your differentiation lately, it might look a little bit weird. But that is how it comes out. It's not hard. You differentiate using the power rule. The 1 differentiates to 0. It's a constant. And this is x to the 1/2. So he'll differentiate to 1/2 times x to the negative 1/2, which is this. Also my bounds. When x is equal to 0, z is equal to 1. And when x is equal to 1, z is equal to 2. And even though that's easy enough to calculate in your head, I still recommend writing it down, because if you make a little mistake in your head when you do that calculation, you'll have a hard time finding it. I make mistakes here sometimes, and sometimes it's very helpful for me to have this and go, oh shit, that's where I messed up. So now let's see what happens if we try to make this substitution go. My old integral ran from 0 to 1. My new integral runs from 1 to 2. 1 over 1 plus root x to the 4 becomes 1 over z to the 4. But I still have this dx here. And I can't have dx's. I need to get every last thing in terms of my new variable. So I need to get dx written in terms of z and dz. And here's the trick. I'm going to take this substitution, or I'm going to take this equation relating the two differentials, and I'm going to solve it for dx. So I get 2 times the square root of x times dz is equal to dx. That's okay. I can go ahead and plug that in. So this is the integral from 1 to 2 of 1 over z to the 4 times 2 square roots of x times dz. So now I got rid of the dx, and I was able to replace it by a dz, but I introduced this x. So I still don't have everything in terms of the new variable. This is definitely not a constant, right? X is a variable. I can't just pop that out and ignore it. So what do? The 2 can come out. But I still have this root x. That's a problem. I can't proceed with the integral until I've put everything into the new, in terms of the new variable. And the trick is going to be to look back at your substitution. Sorry, I see there's a message in the chat.
You solve for x, like under 2 square root of x dc dx, you leave the x by itself.
Yeah, that's the idea. So I can go back to my substitution and try to find a way to write square root of x in terms of z. So let's say maybe recall. z is 1 plus root x. That's the definition of z, which means z minus 1 is equal to the square root of x. So this square root of x term right here, I can replace by z minus 1. So this will be 2 times the integral from 1 to 2, 1 over z to the 4, and then this square root of x is parentheses z minus 1, and dz is dz. So now we've successfully implemented that substitution. Now the integral is entirely in terms of the new variable. And if I want to continue from here, I have to do a little bit of algebra. That's the same as z minus 1 over z to the 4 being integrated from 1 to 2. And then I can split that up. That's z over z to the 4 minus 1 over z to the 4. So we can split fractions across their numerator like that. Yeah, neat, right? And then from there, we can simplify each of those pieces and integrate them on their own. This is the same as 1 over z cubed, or z to the negative 3, so I'll go ahead and write it like that. So this is 2 times the integral from 1 to 2 of z to the negative 3 minus z to the negative 4. And each of these is a power rule thing. So I'll add 1 to the power and divide by that new power. And that will be my antiderivative step. So if I add 1 to the power of negative 3, I get negative 2. So this is going to be z raised to the negative 2 divided by negative 2. And then this guy, same sort of thing. It's going to become, that minus is this minus. I'll have z to the negative 3 divided by negative 3. And all of this is evaluated from 1 to 2. Questions so far? So the trickiness here is definitely in the differential, right? I didn't have something here that could just be soaked up and called dz, like I had that cos x term in the previous problem that was just ready there. It's exactly what I needed. Here I didn't have anything ready. So I was able to solve my differential relation for dx and then plug that in. That gives me the dz here, but now I've got x's and z's together. I can't have that. I can't have my variables mixed. Everything needs to be in one variable. So I need to find some way to write this piece in terms of z. And the trick was to go back to our substitution and solve it for the relevant piece here. You could have solved this for x and then plugged that in here. It's just a little bit less clean. But there's the question, how do I write root x in terms of z? Well, here is my substitution. So root x is z minus 1. So then I replace the root x by z minus 1. Then I combined these two pieces, right? This is being multiplied. So the way you multiply fractions is straight across. This is z minus 1 over 1. So you multiply 1 by the z minus 1, and z to the 4 downstairs you multiply by 1. That gives you this. And then I split those fractions up. This over this minus this over this. Rewrite those as powers, and then apply the power rule. The last step is the evaluation step. Is there anything obvious that I can factor out of here? Not really. So I would write this as 2 times, no, I'll plug in my upper bound. I'll have 2 to the negative 2 divided by negative 2 minus 2 to the negative 3 divided by negative 3. And from this, I'll subtract what I get when I plug in 1, which is just going to be 1 over negative 2 minus 1 over negative 3. And of course, there's going to be some amount of simplification that we can do. But for grading purposes on a test, at this point, I would go ahead and give you full credit, unless there is something obvious like, you know, not knowing what the natural log of 1 is, or not knowing what the sine of pi over 2 is, that we really should simplify. But from here, we'll do a little bit of simplification. I'm not sure what you're asking exactly, Gustavo. Could I ask you to clarify a little bit? Like, are you asking about going back to the original variable or something else?
Oh, yeah, I mean when you replace like a square root of x by c minus 1.
Mhm.
That's what I mean. If I have something similar, but instead of being a square root of x, it is, I don't know, an x squared, can I use the same method?
Yep. Yeah. So the worst case scenario, if you're having a hard time figuring out how to replace something like this by the appropriate z stuff, you would do just that. You would go back to the original substitution and just solve it for x. So if I did that here, I would get x is equal to z minus 1 all squared. And then the square root of x would be the square root of z minus 1 all squared, which would cancel and just give us the z minus 1. So yeah, you can. Instead of doing it like this, you can just solve for x all the way and then plug that in. That would work also. Is that what you're asking?
Oh yeah, thank you.
Okay, yeah, and as you run into questions like that, especially working the homework, send me a picture of your work and ask, like, is this kosher? And I'll be happy to give you a nice thorough answer. So our last step here would be to simplify
Okay, thank you.
it. 2 to the negative 2 is 1/4. So this is 1/4 with a negative 2 downstairs, which is a negative 1/8. And then we're going to subtract this. 2 to the negative 3 is 1/8. With a negative 3 downstairs is a negative 1/24. So this is going to be plus 1/24, the two negatives making it positive. And then from that, we're going to subtract this difference. This is negative 1/2 plus 1/3. And we can keep going a little bit. Negative 1/8 plus 1/24. So what would I need to do here? I'd have to multiply by 3/3. And so this would be negative 3 plus 1 is negative 2/24. And from that, we're going to subtract this difference, negative 1/2 plus 1/3. That's going to be a negative 1/6, right? I have to multiply this guy by 3/3. So that's negative 3/6 plus this guy, which multiplies by 2/2. So negative 3 plus 2 is negative 1/6. And then you can have a common denominator and subtract these and multiply by 2. But I'm out of paper here, so I will go ahead and stop here. I'll let you simplify that fraction further if you want. But yeah, this is a good example of a substitution problem where the differential isn't right there for us. And I'd like to do one more kind of sneaky substitution thing like that. But before I do, are there any questions on this guy?
A quick question. I was just wondering, like, just to clarify, you can use any scientific calculator as long as it's not a graphing calculator, correct?
Pretty much.
Like for
If you're curious about whether a particular calculator is okay, send me a Canvas message asking about that particular calculator. There are some out there which will do silly things like find mins and maxes, even though they can't get like evaluating inverse trig functions exactly. Those sort of things we don't want. But if you're curious about a particular calculator, just send me an email or a Canvas message asking. But yeah, as a rule of thumb, any scientific calculator should be fine.
okay, yes, sir. Thank you.
All right, cool. Okay, let's do one more little substitution problem then, and let's make it something a little bit clever. That one is fun, but I want to save him. Which one of these? Oh, we can do that. That's okay. Or we could do that. Let's do, yeah, let's do that. Let's do this. This will be our last problem for today. And then starting tomorrow, we're going to talk a little bit about volumes. Or sorry, starting on Wednesday, we're going to talk a little bit about volumes. So let's look at the integral from 1 to 2 of e to the 1 over x divided by x squared dx. So we need to figure out what to substitute for, and then we need to make the substitution go. The thing that I see here that makes this integral weird is the exponent here being 1 over x. If this was like e to the x or something like that instead of e to the 1 over x, that looks a little bit more like stuff I know what to do with. So I'm going to try to substitute z equals 1 over x. Yeah, good. Now then, remember that's the same as x to the negative 1. So when we differentiate to find dz, that will be negative x to the negative 2 dx. In other words, here dz is negative 1 over x squared dx. Also, I'm going to change my bounds. When x is equal to 1, z is equal to e to the 1 over 1, that's just e. And when x is equal to 2, z is equal to e to the 1 over 2. So here's everything I should need to make my substitution go. My old integral ran from 1 to 2. My new integral runs from e to the 1/2. And this is e to the z times 1 over x squared dx. And the question is, well, how do I get rid of the 1 over x squared and the dx? I have to come back to this. And I see that that's almost exactly dz. This piece right here isn't dz, it's the negative of dz, right? Because dz is negative 1 over x squared dx. So if I want to finish rewriting this in terms of z, it's the integral from e to e to the 1/2, e to the z times. Sorry, go ahead.
Why did you plug in e when you substituted for z? When you're finding the new bounds, z is equal to 1 over x. There's no e in z.
Oh, thank you. Yeah. I'm sorry. Yeah, we didn't substitute z equals e to the 1 over x. It's just 1 over x. Yeah. So these bounds should just be 1 and 1/2. Thank you. Yeah, sorry. So we're integrating 1 to 1/2. Thank you. Yeah, we're plugging into this to get our new bounds, right? So when I plug in x equals 1, z is 1 over 1, which is 1. And when I plug in x equals 2, z is 1 over 2. Yeah, thank you. I'm sorry. Everybody hear that? What Simon said there is exactly correct. Yeah, I goofed up on the new bounds.
And you're not going to change them since 1/2 is smaller than 1?
Well, it's important that the new lower bound is what comes from the old lower bound, and that the new upper bound is what comes from the old upper bound. We can then flip them around, and that will be what swallows up the negative here. So if we're comfy with all of this, this 1 over x squared dx, that's the negative of dz, I can pop that negative out front. That's negative integral 1 to 1/2 e to the z dz. And then the negative and swapping the bounds will give me positive integral 1/2 to 1 e to the z dz. But make sure that when you first replace them, you put the new lower bound as being whatever came from the old lower bound, and the new upper bound being whatever came from the old upper bound. If you switch them, without doing this carefully, you might end up being off by a minus sign.
Do you really need to switch the limits, or you can stay with 1 and 1/2, 1 in the bottom,
yeah,
1.5 in the top?
This is fine as long as you've got the negative from the dz. Then you can leave it like this.
Okay.
Integral 1 to 1/2 e to the z dz. But Simon asked about this, so I thought we would go ahead and write it out. Either one is fine. Yeah, either of these integrals is a fine completed substitution. And then from there, our antiderivative, the antiderivative of e to the z is just e to the z. So this is e to the z evaluated from 1/2 to 1 like that. Or if you did it like this, you'd have a negative and these bounds would be switched. Either one is okay. So then finally, if I evaluate, this will be e to the 1 minus e to the 1/2. Okay. So I think we are out of time here, right? 12:50. Yeah, okay. So this is where we're going to stop. I will go ahead and open up your first homework on WebAssign, which is going to be a mixture of review problems from 5.5 and some newer stuff, depending on how far your Calc 1 class made it. Tomorrow or Wednesday, we will talk about areas between curves and a little bit about average value, and then we'll be ready to move on to talking about volumes and things like that. So please go ahead and get set up in WebAssign. I will, before we leave, I want to take attendance here. So please don't sign out just yet. Are there any last minute questions? Turn off my screen share.
Oh yeah, I just want to know very fast about the office hours, how they are going to be, or when they are going to be, or you don't have it ready yet, or.
So the way office hours are going to work, after we've all decided on days and times, I will have a standing Zoom meeting and I'll post the link in Canvas on the syllabus page. So if we decide office hours are going to be Tuesday and Thursday at 10 a.m., then just on those times, on those days, you'll go to Canvas and click that Zoom link, and I'll have a big open meeting like this where we can talk. And if we want to, we can go out into breakout rooms so we can talk privately. There will probably be a waiting room system there so that I can admit people the same way I would at a regular office hour. So if you want to talk privately, you don't have to worry about somebody else hearing you. But it's going to be over Zoom. So it'll be very similar to our class meetings here, only I'll be mostly working on the board you see behind me, and we'll be bringing people into the meeting one at a time.
Okay, thank you.
Yeah, of course. So please hang around just 1 second longer while I can get everybody who's here marked as having attended. And then we will be able to scoot. Actually, let me see if Zoom saves this stuff. I don't know if it does. Doesn't. I don't trust it. So here we have our list. Clear all more. Alrighty, I think I should have this saved now. If you could, just really quick, everybody go ahead and type the word here or something like that into the chat, because I know it'll save the chat log even if it doesn't save exactly who was here. So yeah, if you could just type here in the chat, then I will be able to enter the attendance from the chat log, and that will be the easiest thing to do. Once you have done that, you are welcome to sign out, and I will see you guys on Wednesday.
Thank you.
You're welcome. Yeah, have a good one. Almost done, sweetie. What's shaking? Yeah, you do. You need an access code. You can get in there without the access code using the temporary access, but we'll get you a code. I think we can get it straight from Cengage for about 80, 90 bucks. That's sweet, Lucas. I'm glad it was good. I'm glad it's helpful. Say that again, sweetie. I'm almost done. I got Just 1 second. Sorry. I gotta take attendance, otherwise they won't get their financial aid released. Did you guys have a question hanging out? Sorry. Anything you wanted to talk about?
I had a. It's not related to this class.
Okay, yeah. Well, what's up?
I was interested because like I'm studying computer science, and I was interested in studying like crypto analysis, and I was want to know if like you have any experience with that, and if you could maybe point me in the right direction of where I should study this.
So my background is not super crypto focused. I have a little bit of knowledge of like RSA cryptography, but the right people to talk to there would be Philippe Pinot, Dr. P, who you may remember coming from some math team meetings. Yeah, Pinot, but he goes by Dr. P. He's a very tall, bald Frenchman. And also there's a guy, Jonathan, at UF's math department. Jonathan, what the hell is his name? UF math cryptography. I'm gonna say, what the hell is his name? No. King, yeah, Jonathan King, King at UF. He's going to be your best guy. He does a lot of crypto research, and he's in town here.
In Gainesville?
Yep, yeah, he's a math professor at UF, Jonathan King. He's a very silly guy. He likes to sit down and play chess with his students. He's very, I don't know what the right word is. Gets excited about things. He gets very, very excited about things. He always has his own way of doing stuff, and he wants you to do it his way. But he's an excellent professor, and his research specialty is cryptography.
Okay. And how would I reach out to him?
I would email him. So if you search here, let me see if I can find his website. Yeah, here we go. I'm going to paste it into the chat here. So if you go to that URL, that is Jonathan King's personal website at UF, and it should have all of his contact info. Yeah, so you see his email address there is squash@ufl.edu. They got his phone number and a mailing address if you want, but I would send him an email, let him know that you're an enthusiastic math student at Santa Fe, very interested in cryptography, and just see what he has to say. I know that he has a bunch of papers out. You could read those. He probably also has class notes for his own cryptography class, which runs as a number class there, I think. It's a special number theory class. I think it's graduate level. I'm not sure. But that I also think there's probably an undergraduate version. Looking at his teaching page, current courses.
Did I email him from Santa Fe or my normal email?
From your Santa Fe email. I think that's probably going to be the way to go. And then, yeah.
I don't see his.
If you look deep in his website there, if you click on the courses and then past courses, on the left-hand side, about halfway or 2/3 of the way down the page, you'll see number theory, introduction number theory 2, and then below that, NT and mathematical cryptography, spring 2016. Those will be the lecture notes for his crypto class.
How did you get to that? I'm on the link that you sent. I don't see anything that says course.
So where do we go? Teaching page. So on the left of his main page, if you go to teaching page, parentheses, course, and then click on past courses, you'll find it there, or you can just follow the link that the second link that I pasted.
Okay, I found it.
Yeah, he's a very interesting guy, and I think you will find the conversations with him at least to be engaging, if not really informative.
Okay, I appreciate it. So just email him through Santa Fe, and then that's it.
Yep, yeah, that'll do it.
Okay.
And
thank you, John.
Of course, yeah, you're welcome, Simon. So what were the other questions here? Ryan wanted to know, is the answer for the last example there 1/6? It looks like this should be a negative number to me. -1/8 plus 1/24 minus negative, yeah, so that's going to be -1/2. Oh, wait, maybe this should become a plus. Yeah, that's a -1/6, so we're going to add that to that. 2/24 is the same as -1/12. -1/12 plus 1/6 should be 1/12. Yeah, yep. So it looks like this should come out to a 1/6 at the end. I can switch back to the dot cam for you here really quick. There we go. You should be able to see this now. So that example, the one with the square root, came out like this, right? So I had -8th plus 1/24, which is a -2/24. And then I had -1/2 plus 1/3, which is a -1/6. So I'm going to subtract -1/6, making that a plus 1/6. And then out here I have this 2. So finally, if I combine these, this is equal to 2 times -1/12 plus 1/6, right? 2/24 is the same as 1/12, and then I multiply this by 2/2, and I get 2/12 minus 1/12. So this is 2 times positive 1/12, which should be positive 1/6. So yep, that's it. Very good. Sorry, the chat didn't come up here. I gotta learn these hotkeys. Alt-H. Maybe it's, I don't know why it's not showing up. Oh, there it is. Okay. Yeah, and then any other questions? All right, cool. Have a good one. I'll see you guys on Wednesday. Stop sharing.